Hello everyone, good morning class. It's your host, ichino-ani here. Wow. Weather is just wonderful today, isn't it? Today is September 8th, a bright and shiny Monday, and you know what that means. It's time to open up our archive and look at a super interesting trending topic together. Let's see what we've got today. Right here it is. The title is CHRONO GRAPH, a real-world graph-based multivariate time series dataset. And the curl is shots://abs/24/5.4449. That's a long one, isn't it? CHRONO GRAPH sounds like the name of a cool superhero. Let's find out what its superpower is. Okay, everyone, let's put on our thinking caps. So, what problem is this paper trying to solve? Or, imagine you're trying to keep a big, complicated machine running smoothly, like on a huge website or a whole factory. These things are made of hundreds of tiny little parts or services that are all talking to each other. It's kind of like our classroom. Each of you is a service, and you're all connected by invisible strings of friendship and conversation. If one person starts feeling sleepy, it might make their neighbor feel sleepy too, right? The problem is, most of the ways we teach computers to watch these systems only look at one student at a time. They can tell if one student's napping or brain power is getting low, but they can't see the invisible strings. They don't understand that a problem with one service might spread to another and then another. The existing datasets for training AI are often too simple. They might only track one thing, like traffic on one road, or they don't have a clear map of how everything is connected. So it's really hard to teach AI how to predict big problems that ripple through a system. That's where our superhero, CHRONO GRAPH, comes in. This paper introduces a brand new dataset, which is like a super detailed textbook for AI. This textbook comes from a real, big company's computer systems, and it was collected over 6 whole months. What makes it so special are 3 things. First, it tracks many things for each service at once, not just APU, but also memory usage and network activity. This is called being multivariate. It's like tracking a student's energy level, hunger, and happiness all at the same time. Second, it gives us the actual map of all the connections. We can see exactly which service talks to which other service. You get to see all the invisible strings. This is called the path topology. And third, it includes labels for when things actually went wrong. Real engineers mark down when there are actual incidents or disruptions, so the AI can learn from real-life examples of problems. This combination of lots of data streams, a clear connection map, and real problem labels is super rare and super useful. Now you might be thinking, okay teacher, that's cool for big computers, but what does this mean for me? That's a great question. Let's think of some examples. First, let's talk about something like a big social media app, or maybe TikTok or Instagram. These apps are made of hundreds of tiny microservices. One service handles your feed, another handles stories, another handles messages. They are all connected. If the service for stories starts having a problem, it could slow down the service for your feed. With technology built in a dataset like CHRONO GRAPH, engineers could predict this slowdown before it happens. They could see the problem starting in one corner of the system and watch how it's about to spread along the connections. They can fix it before we even notice anything is wrong. That means fewer crashes and a smoother experience for all of us. Okay, for a second example, let's imagine a smart city's traffic system. Every traffic light at every intersection is a little computer, a node, and a giant graph. The roads are the connections, the edges. Each intersection is collecting lots of data, like how many cars are passing, how long they're waiting, and so on. Now if there's an accident, that's an anomaly. The traffic jam will start to spread, right? Or will ripple through the city's road network. An AI trained on this kind of graph data could predict exactly how the jam will spread. It could then automatically change the timing of other traffic lights in nearby areas to help clear up the congestion. We even tell our navigation apps to find a new route before we get stuck. Isn't that neat? And for our third example, let's think about how a package gets to your house. It's a long journey, a supply chain. It goes from a factory to a big ship, to a port, to a warehouse, and finally to a delivery truck. This whole chain is a complex graph. Each point, like a warehouse, has lots of data. If a big storm closes a port, that's a major disruption. This technology could predict the ripple effects. It could tell a company not only that their shipment will be late, but also which other warehouses and delivery routes get backed up as a result. This helps companies plan ahead and keep things moving as smoothly as possible. So, how is this different from what we already have? Well, our traditional methods for spotting problems are usually... That's a fancy way of saying they don't know about the connections. They look at one service, and if it's too high, they send an alert. They're like a hall monitor, who only sees the one student who is running, but doesn't see that they were just part of a big game of tag with 10 other kids. This new approach is topology, where it sees the whole game. The paper also tested some really powerful new AI models, called foundation models, like CHRONOS. These models are super smart at predicting the future for one thing at a time. But the paper found that when they tried to predict things far into the future, from this complex system, they didn't do so well. Our performance got a lot worse over time. This shows that even the smartest models need to understand the connections, a graph to make good long-term predictions in a complicated environment. So in conclusion, this CHRONO GRAPH paper isn't just about a bunch of data. It's about providing a new, well-needed tool for the whole research community. It's like giving everyone a brand new, powerful microscope to study how complex systems work and sometimes how they break. By understanding these connections, we can build smarter AI that can manage everything, from our favorite apps to entire city infrastructures, making them more reliable and efficient for all of us. What a fascinating study. Alright class, that's all the time we have for today. Great job listening everyone. I'm ichino-ani, and I'll see you next time. Bye bye.